Hello, and welcome to the Energy Transition Talk, the podcast that explores the challenges and opportunities of transitioning to a low carbon future. I'm Paulina.
I'm Jim.
And I'm Justine.
And we're your hosts for today.
In this podcast, we seek to break down some of the most complex and important issues regarding the energy transition and how it impacts us. In each episode, we will tell a story by bringing you various perspectives about the energy transition so that you can make the best and most informed decisions for you and your communities.
In this episode, we'll focus on the topic of criticality, which refers to the importance and availability of certain minerals that are essential for the energy transition.
We hear the phrase that the energy transition shifts the economy from big oil to big mining. While the wind and the sun seem to be emission-free resources of energy, that is not the end of the story. And as we will hear on the episode, critical minerals and the supply chain for renewable energy sources are part of the story. In our expert segment, we have the pleasure of hearing from Lauren Bridges from the Harvard University and Zane Cooper from the University of Pennsylvania about the research collaboration on critical minerals and e-waste.
We then shift to the topic of lithium and speak with Prachotan Bathi, a master's student who works for a clean tech startup focused on sustainable extraction for the electric vehicle or EV supply chain. We get the inside scoop on how sustainable lithium mining is at its current state and whether EVs are actually more sustainable than gas vehicles.
Here's our discussion with Lauren and Zane. Lauren and Zane, thank you so much for being here and joining us in this conversation. I would first like to introduce both of you, Lauren and Zane. So Lauren Bridges is a fellow at the Berkman Klein Center for Internet and Society at Harvard University, who researches the social and environmental impacts of digital infrastructures. She publishes work on surveillance infrastructures, digital labor, digital failure, among other topics. And she explored the global policy challenges to addressing the e-waste crisis as it relates to the impact of industrial computing and logistics and operations. She received her PhD from the Annenberg School for Communication at the University of Pennsylvania. And Zane Cooper is currently a doctoral candidate at the Annenberg School for Communication at the University of Pennsylvania, a doctoral fellow for the Center for Advanced Research in the Global Communication, and a consulting researcher at the McHarg Center for the Weizmann School of Design, and where he's currently working on the thematic development for the International Green New Deal Atlas. Zane Cooper and Lauren Bridges also collaborate on the e-waste trail and sources extractions. So thank you so much, Lauren and Zane, for being here.
Thanks so much for having us. We're excited to be here.
So maybe first we would like to maybe just set the stage. So thinking about critical materials and why they are important to the energy transition, could you maybe help us map it out a bit?
So critical materials and why are they important to the energy transition? This is a very loaded topic with very many layers, but put simply, critical materials in giant air quotes, are a set of minerals that are essential for building things like wind turbines or solar panels or digital technology that will help improve energy efficiency, things like this. And so these minerals are wide and varied, and they include everything from like nickel, graphite. Graphite's having a resurgence. Rare earth minerals, which I study rare earth minerals a lot, more the social, cultural, and ideological entanglements of rare earth minerals. And these are roughly speaking, a set of 17 distinct minerals in what's called the lanthanide series. And these are like very idiosyncratic. They're all used for slightly different things, but they're very important in digital technology, and especially in magnetic motors, which is and permanent magnets, which are in literally almost everything. Wind turbines use huge rare earth permanent magnets in their motors. Every single cell phone, every single laptop, every single hard drive, and every single server room across the world has rare earth elements in them, and specifically the rare earth permanent magnets, and so they're really important for this coming energy transition, which is going to, as we move off of oil and fossil fuels, there is going to be, and already has been, a sort of a rush for these minerals, which we're going to need a lot more of. Lithium is another one, right? So like there's this big rush to electrify all vehicles, and this means that we need a lot more lithium, and so there's a rush around the globe to find and exploit lithium reserves in places like Chile. There's I think there's one in Portugal. There's a controversial one in this indigenous region called Pahimaha in or Thacker Pass in Nevada. And a lot of these deposits are controversial. They're being fought by, the development is being fought by indigenous activists and things like this. And you see this happening across the landscape of the burgeoning critical mineral space. You're seeing a lot of contention over new mine development, but a lot of this mine development is being supported by this idea that, well, these minerals are critical and we need them. If we want the energy transition to work, if we want to get off fossil fuels, we need these minerals. And so it's a net positive thing, right? That we extract these minerals and that we have them because we want the energy transition to happen. We want it to work. And so obviously these minerals are critical. But the question that, when you came to us about this podcast, the question, that I've been sort of dancing around with my dissertation work is, okay, so these minerals are needed for the energy transition. We call them critical, but like, what does criticality mean? Critical for whom, is my question. Like, who is saying that they're critical, and who benefits from this imposition of criticality? So I guess I'll leave it there and pass it to Lauren, because while my research deals more directly with critical mineral extraction, Lauren, your work on industrial scale computing feeds right into this, because it's directly ideologically related in this like big feedback loop that we seem to be getting ourselves in. So I'll just pass it off to you and see if you can respond to this word salad that I just spewed out of my mouth.
It's always a joy to listen to your word salads, Zane. It's great. I think you've given us a really good comprehensive introduction to what criticality is, and raising the important question of critical to whom and to what end. I guess I'll add to the discussion that critical materials and critical minerals are largely defined in the interest of the state. So they're designated as critical by the state. So DARPA, for example, defines critical materials as essential to the US economy and as essential to national security, and any kind of elements that might have some kind of supply chain vulnerability. So this doesn't necessarily mean that either they're rare or they're critical in terms of meeting our energy transition needs. They are critical for that, but they're critical in terms of the needs of the state to meet both economic outputs and to meet national security outputs, and in the energy transition as well. So I think, just responding to what you said, Zane, what is important to recognize is that criticality in the way in which it's been framed in the public discourse is largely determined by the state and the state's needs. And so this is also why, renewables and energy storage solutions that are going to be required for the energy transition are becoming of the utmost importance to the state. So, renewables are going to rely on all kinds of critical minerals for solar panels and from wind turbines and from marine energy production, and same with energy storage, lithium, Zane already mentioned, which are going to be required to meet the energy transition.
So my question would be, how do you both come to this topic, and what makes you interested in the energy transition, both from where you're coming from and maybe further on we can elaborate on how you started collaborating, thinking of the flows of e-waste?
Yeah, so Zane mentioned that my focus is more on the industrial computing model of the digital economy. So I'm not specifically focused on the energy transition or critical minerals themselves, except for how they relate to this industrial computing paradigm within which we currently operate. And by that, I'm talking largely about internet infrastructures, digital infrastructures, and cloud computing. My work specifically looks at the local impacts of data center development and logistics development in local communities. So what is the political process of deciding where development can happen and should happen? And then also, what are all the materials and resources that go into those data centers that are required to sustain them? So here is where you have tension around water allocation or water supplies and threats to the water supply, impacts on the land, impacts to air quality, energy and grid capacity concerns, which are creating all kinds of frictions and trade-offs, especially that are going to become exacerbated as we continue the energy transition. There are already several cases where data centers have consumed the electric grid allocation for a local community, which is creating a trade-off situation where other activities can't then go forward. And these activities are really important. For example, in London, data center development allocation for, well, the allocation for electric capacity for data centers meant that much needed housing couldn't go forward and housing developments were being halted. And there's currently a housing crisis in London. In Northern Virginia, data center development has been going kind of, it's been increasing at a rapid rate. And this is creating friction in the local community around the local water supply. And several other issues around noise, around the electric grid capacity as well. So in Virginia, they recently announced that they're going to run out of capacity in the electric grid. I think it was actually supposed to be in June of 2023. Now there seems to be a little bit of backtracking on that, so it's uncertain where they're at the moment. But initially, like last year, they announced that they were going to reach electric grid capacity in June of 2023. And as a result, they put up a proposal to allow for the relaxing of emissions by data center operators. And so that would allow them to run diesel generators 24/7, which would then impact the air quality of the local community. So this is what I'm talking about when I mean that data centers are also entangled in all of these energy transitions, not just in terms of the energy that they consume, but also in the fact that they're going to provide critical infrastructure for electrification, for electric cars, for charging stations, for the management and delivery of energy. So my work is I guess entangled in this digital supply chain for the energy transition.
My work is a lot more directly connected to critical minerals. I started my PhD journey, or my academic journey rather, doing research on like I wrote my MA thesis on the history of 3.5-inch hard disk drives, which are the most commonly used form factor of hard disk drive still to this day, and it's been the most commonly used form factor since the 1980s, mid 1980s. It hasn't of course we've there have been advancements in storage density and things like that, but I come at my study of computing and data infrastructures from this place of understanding already that once you get to a data center, that data center and the stuff inside it is already so deeply entangled in all sorts of different mineral and material supply chains, and most of these things remain unaccounted for in most studies of like digital infrastructure and data centers and things like that. So I came up with this idea of data peripheries as a way to sort of attend to all of the stuff that exists outside of the data center, but that the data center depends on. And so this sort of way of thinking led me to thinking more deeply about the broader relationships between data infrastructures, energy production, and resource extraction. And so my dissertation looks at how all of these regimes are related and how we can talk about them together as a singular process and not just as siloed areas of concern. Like, oh, we have these problems with data centers over here that we're addressing, or we have these problems with energy production over here that we're addressing, or we have critical mineral policy over here. But really, these are all sort of the same thing. They're all bound up together, and they feed off of each other in various ways. And so I look at, in my dissertation, the cryptocurrency mining industry in Iceland and the burgeoning rare earth mining industry in Greenland, and sort of how they relate to each other in all these weird and dynamic ways, largely ideological, and how these ideas of what the relationship between the digital and green future and like the Arctic imaginary is, how these mining regimes are sort of mixed up and all that. So all that goes to say that my work largely deals with bringing together conversations about data infrastructures, energy production, and resource extraction to try to find paths through them, so that we can think about them as a singular related process.
This is all fascinating, and I could go on a tangent to ask you both very different and specific things. But I want to think about like these ideas that are tying us together. So thinking about these sources that you've been talking about, the supply chains of critical minerals and renewable energy technologies that you've mentioned, like wind turbines and solar panels, and batteries that bring all of these in conversations. Could we maybe think about or talk about what these sources are and how they are impacting our environment, how they're impacting the way that we understand this type of materiality, and also thinking about sustainable and ethical supplies of these minerals. Like, what is the conversation, and why is it important that we think about it and we know what is happening out there?
So I think that a lot of times when we're talking about the energy transition in like a big, broad policy way, you know, a lot of folks tend to talk about it as, okay, so we have our fossil fueled infrastructure and we need to replace it with a renewable energy infrastructure. So we need to take away this coal, this natural gas, this oil, and then we need to replace it with wind and solar and, you know, or geothermal, or, you know, we need to, it's like a shutdown and then replace, which is sort of like a graft. So it's like, I feel like most energy policy, renewable energy policy discussions, whether they know it or not, are conceiving of, well, we just need to take all of this stuff and we need to graft the new system onto the old system, and then that will solve everything, right? Because then everything can stay the same and we can keep growing, but we can do it in a sustainable way. Well, that's not ever going to work. Because there are so many problems with that. The world is designed around fossil fuels right now. Like all of our infrastructures, everything, like down to how individual people behave on a daily basis and move from point A to point B, all of this is built around the idea and affordances of fossil fuels. And so what the renewable energy transition will really take is a rethinking of infrastructural design. So, you know, we can't just take all of the gas-powered cars off the road and replace them with electric cars. That's not really gonna work. We're gonna like the lithium supply chain is going to be strained. The copper supply chain, which is something that nobody really talks about, but that's going to be strained. And also, it's just not feasible. And so and this goes back again to this idea of criticality. Whose criticality, right? You know, if you know, like Lauren said, the state or, you know, multinational corporations are sort of like defining what the energy transition should look like, but really they're largely wrong, because you can't have a durable society that is sustainable, that continues to live in ways that were created and maintained through fossil fuel use. Like, need something different. And so, like, I like this org, the Climate and Community Project. They're a climate think tank, and they released recently a report on Theoria Francos, who's a great scholar of the politics of critical minerals, sort of led this study. It's called Achieving Zero Emissions with More Mobility and Less Mining. And all this report basically says is that, you know, we have this idea of what lithium demand is. However, if the United States just prioritized building out public transportation infrastructures just a little bit more, that demand could be reduced by up to 71%. And that's crazy, right? And that's not from any sort of like new build out of energy infrastructures or anything like that. It is a slight change in investment priorities and a slight change in behavior. So for me, the idea of criticality and you know, critical minerals and, you know, all these wind turbines that we're going to need to keep up with energy demand and everything. Well, like, I think we should question the energy demand. I think we should question the demand. Where's that demand coming from? Who is instituting it? Who is claiming that there is this much demand? and how can we, and is this demand even feasible? Does it work? How do we even need it? And like a lot of times the answer is no. Yeah, I'll stop there and hand it over to Lauren, because like this is a problem with like industrial scale computing too, because especially with this with the growth of AI infrastructures, we're going to need to build out all these new data centers and much more high capacity data centers that use a lot more energy too to train and maintain these new AI models. There's so much new data center construction, and it's predicated on the fact that, well, we need it, right? It's the future, but do we? Whose future? I don't know. What do you say, Lauren?
Yeah, you've raised so many issues that I want to respond to briefly and also respond to the question. But just starting where you left off around AI infrastructures and AI models, and how we just keep building new platforms and new devices and new services that are reliant on this industrial computing model. It's so well and great that we're like, oh, cool, here's a new device, or here's a new platform and a new way to understand the world with this AI-backed technology. But all of that relies on the industrial computing model. And equally in the energy transition, I mean, AI is currently being used to locate energy sources. It's being used to locate critical minerals, and then those minerals are then like developed and put into electronics that then go back into the data center. So it has this reciprocal relationship with the data center. I think, Zane, you mentioned something that I want to pick up on that also relates to this, like the industrial computing, which is around rethinking the infrastructural design of these things. So, with data centers, the discussion is often around how to make them more sustainable as well. So there are so many different solutions being posed for that. Data centers are being dropped into the sea, where they're using marine power to keep the servers cooled and to power the servers. They're being put in caves. There are solar powered data centers, wind powered data centers. There are new kinds of ideas around recycling the waste heat, so that heat that is generated from all of the computers running can be used to like heat homes. And these are great ideas. None of these are bad ideas. Dropping them in mineral baths so that you can reduce the amount of water required to keep the servers cool. So these are ideas to make data centers more sustainable. But I think what is more crucial to understand here is what is driving that demand. And part of that demand is around, the AI models that we can continually want to build. But the other part of it is related to electrification as well, which again will be reliant on this industrial computing model. And a lot of the priorities are being set, as Zane said, by either state actors or local actors or corporations. They're the ones telling us that we need more of these infrastructures. But instead, what we could do is just rethink this model completely. Is this what we need to do? Do we actually need to yes, we need to make data centers more sustainable for sure. But do we need to find an industrial solution? Do we need to keep scaling them? Because the way in which they are being developed to meet our constant and continued and accelerating demand for these infrastructures is, for me, a bigger concern. And at this point, they are deeply, deeply unsustainable, from their energy production and energy consumption, which is still largely reliant on fossil fuels, to their water consumption, the way in which they impact land, and then air quality as well, with related to energy production, and then e-waste as well, which is, I think something that we're eventually going to get to in this conversation, and how these industrial infrastructures are producing massive amounts of waste. And that waste can be categorized in various different ways, which is something that our project aims to address. But essentially, they're just deeply, deeply unsustainable infrastructures. So I think the question is more about, what kind of digital future are do we want? What kind of relationship do we want to the digital? And how are we going to make a more sustainable relationship with our digital infrastructures?
I think that sustainability is key here when we're talking about the energy transition. So we are thinking about not only switching from one source to another, as you were mentioning, but actually a transformation of our relationship to materials, to infrastructures, to communities, which are at the root of this. And we're also talking about political interests and economic interests. And I don't know, maybe we can think about how can we address these challenges of sustainability, of recycling, of using or reusing critical materials and minerals. And at the same time, how does that relate to e-waste? So maybe we can tie onto the conversation, like making that bridge between one and the other.
Yeah. So I think that one of the key factors, at least for me, is rethinking like politically what energy is in the first place. And there's a great book by an energy scholar named Kara Daggett, and it's called The Birth of Energy. And she traces how the concept of energy, the one that we think of today as like energy being a discrete thing that is that you can hold and then like move from place to place. Like, you know, I have energy here and then it goes here and then it goes here. This energy that is immediately quantifiable and transportable. This idea of energy really was birthed in the 19th century and isn't really like a full picture of what energy is and what it can be and what it can do. It is a way of thinking about energy, again, that is predicated on fossil fuels, that is based off of the study of coal-fired heat engines. And so, you know, ideas of energy, ideas of entropy, all of these, like the laws of thermodynamics in general, all come out of this environment where fossil fuels were taking over. Industrialization was running, and was full speed ahead. There's, the late 19th century, industrialization had fully taken hold, and so our blanket understanding of what energy is and how it operates in the world, and how we understand it politically, ideologically, socially, comes from this 19th century understanding of energy as a discrete measurable quantity that can be moved from one place to another. It also, became implicated in ideas about efficiency, like work efficiency, labor. This idea of energy was heavily influenced, like Taylorism and assembly line things. This kind of line of thinking. And so, what I am trying to think about is trying to think about energy in like a different way, that is more dynamic, that doesn't rely on a fossil fueled understanding of what energy is. And so in my work, I approach energy not as a thing, but as a process, and more importantly, a relationship between two or more things. And so in thinking about energy as a relationship, it's not necessarily this thing that needs to be produced and that we need to have enough of, but it's the building of good, durable, sustainable relationships between us, our infrastructures, our computing, our energy sources. Like, all of these require good, durable, sustainable relations.
Kind of going back to maybe this idea of a feedback loop, how do you feel that e-waste impacts the energy transition in the work that you've been doing? And like, how can we draw those lines or those connections to the audience that is listening to us, so that we can better understand how we can make sense of all of these kind of different nodes or ideas that are happening at the same time?
That is a really big question, I think. So I think what we've addressed here is that there are various different ways to understand what e-waste is, when it happens, where it is, and our relationship to it. But how does e-waste relate to the energy transition? I mean, I think it relates in the ways in which we understand what is the energy transition itself. Is the energy transition simply a matter of replacing one with another? Is it more transformational in the way in which we understand our embedded relationships, both with energy consumption, energy production, energy distribution, our energy requirements, our reliance on energy? And then how is that related to waste? Well, any time that there's energy production or consumption or use, there is going to be waste. There's going to be so many different forms of waste. And specifically when we're talking about e-waste or digital waste, I think that the energy transition in the way in which we are imagining it currently is completely reliant on digital infrastructures. I mean, I haven't heard any kind of renewable energy solution or energy transition solution that doesn't involve the digital. So if we are talking about energy transitions, then we are talking about waste as well. Zane.
Yeah. So yeah, like Lauren said, the energy transition and the digital transition are like this. They're deeply intertwined, and honestly, they're sort of the same thing, because many of the green energy sustainability solutions that are like, even if we just move to like a consumer level, right? Like how do you get your home to be more sustainable? And more energy efficient? What's the best way currently right now to make your home more energy efficient and lower your electricity bills? Well, you get a Google Nest thermostat, right? And then you start automating, you let it automate temperatures and things like that. So the energy and the digital transition are very, very, very deeply entangled. I think that like as we move forward in this energy and digital transition, which again is often I see as the same thing, like we can ask these questions now about like, well, what kinds of data processing are good and which kinds are bad? I think that cryptocurrency is sort of like opened the gates to that question. And now with AI and other forms of industrial computing getting bigger, we can start thinking more critically about what we want out of our relationships to computing, out of our relationships to energy, things of that nature.
I appreciate you bringing us kind of full circle. And it's been more about more than thinking about critical materials, about rethinking criticality and thinking about what our relationship, what kind of relationship we have to these materials, to the digital, to the futures, and the future of the energy transition. So maybe just as a closing thought, and as we go back to this idea of energy as a relationship and as an ongoing process, and this infinite cycle that is impacting communities and community members, how can these individuals that might embrace themselves as civic agents actually make an impact, or what role do they play? And I think, Zane, you are maybe addressing this a bit in this latter remark, but because we're thinking in this podcast that the energy transition is up to us, it's up to you and me. So thinking about our audience, what can we do differently to make an impact when we're thinking about e-wasting, when we're thinking about the transition through critical minerals and these different understandings that we've been talking about for the past hour or so?
I think in terms of citizens thinking about their role in the energy transition and being, acting in sustainable ways and thinking about energy and its impacts and waste and its impacts, I think the best thing that any one person could do is get involved in local politics, for real. In my research, I've been looking at the localized impacts of development decisions, and the citizens that get involved in those decisions, they, despite all odds, they might be up against developers with very deep pockets that have coalitions and very close and strategic relationships with local politicians. But in certain instances, they can prevent certain developments from coming into their local communities by coordinating campaigns and by using grassroots organization tactics so that they can say, no, we don't want that in our community. It's going to take too much. And this is not a case of NIMBYism, or I think that term is often applied in these local battles, frequently to undermine the real concerns of local communities about the impacts from these huge infrastructures that just take so much from the community. And I personally think that it is dangerous for us to put this burden on individuals, because this is a systemic, structural, and ideological issue. It's something that is baked into policy decisions and allocations for zoning and what is allowed to go where. It is something that is baked into how we structure our economic and social relations built on these infrastructures, which are frequently and largely dictated by global companies because it serves their interests. So for me, I think one of the best ways that citizens can be active participants in the energy transition is to get involved and to look at what's happening in their local communities.
Yeah, I think that's super important. And yeah, I 100% agree, because like all this action happens at the level of the city council, like I think people should run for local office, hold, learn about local politics, state politics, all of these things. It's so important, because so many changes that affect our daily lives are made, like these decisions are made at the state and city level. They're not made at the federal level. And so yeah, getting involved in local politics is key. And it's key not just in the United States but everywhere. Like in Greenland, like this small group of activists, Urani Namik, which means uranium no thank you, they have just been organizing on Facebook for the last few years, and they ended up toppling the Greenland's government and winning, like and the party that they aligned themselves with ended up winning for the first time in like I don't know, like 15 years. And in so doing, they passed legislation that created new thresholds of like zero tolerance for uranium mining, and so like these citizens and individuals, made a choice to get involved, and that involvement like led to a huge victory that's being seen across the world, and in indigenous space communities as a model for how to fight back against some of these companies. But in addition to getting involved locally, I would say one of the most important like perspectives to adopt is to stop thinking at the level of the individual. So like we're often taught to be sustainable humans, right? We need to use paper straws, or we need to recycle, or we need to do this, but that none of that's going to really help or make any sort of meaningful dent. It might make us feel good, which is great, and it's good to cultivate sustainable practices where you use less stuff, like that's great, but at the level of the individual, this isn't going to make much of a difference. We need to start thinking about how the infrastructures around us are designed, what sorts of behaviors and practices they afford, and how we can work to better those infrastructures so that we can have better and more sustainable relationships between us, the energy we use, and the infrastructures that we move through on a daily basis. And so for me, it's about thinking at the level of design. So like how, I have, I do this, I, in my day-to-day life, I get up and I drive a car and I go to this place and then I go to this place and I go to work and then I come home. So how can, what can I do to make my relationships to my transportation, my energy more sustainable? Well, I could stop driving a car. Well, a lot of people have to drive cars in this country because the especially, in Ohio, or, where I'm from in Colorado, it's just impossible to get anywhere without public transportation. So like, you need to start thinking on the level of not of denying yourself access to transportation, but of like, how can I help make public transportation better and more convenient and affordable, so that not only me, but everyone around me can benefit from these changes. So yeah, for me, it's about thinking systemically, I guess, and at the level of design. So not only getting involved locally, but thinking, NIMBYism is often, an individual thing. Like, I don't want this in my backyard. But it's not just about you. It's about everyone. It's about the community. So thinking not only of yourself, but of your community and how your community is designed and who it's designed for. I have one more short thing on the idea of criticality and how it's legislated. So something to keep in mind whenever the pundits in the US start talking about how the US needs these minerals because they're so, we need them for national security. We need them now. It's always so immediate, right? It's always like, oh, we need, suddenly our supply chains are threatened. We need these critical minerals and we need them now. We need to onshore our rare earth production. We need to have domestic supplies of nickel and lithium and blah, blah, blah. This imposition of criticality, this idea that like or the US need, or whatever country needs these minerals now, is totally dislocated from how mining actually works. So like it takes 10 to 15 years to scope and permit a mine, right? And so like if the US is saying we need our critical minerals and we need them now, this urgency doesn't match with what it would actually take to create and maintain these domestic supplies of minerals. So there's like this temporal disjuncture, and often these talks of like whenever critical minerals are brought up in a policy discussion like this, it's often to rile people up, make them afraid that all of a sudden the US is in danger of losing their supplies of rare earths, and we're not going to be able to have our cell phones, and we're not going to be able to do this and that. But that's it's just often not really the case. And whenever, I guess, in short, what I'm saying, whenever any politicians try to yell at you about critical minerals and how we need them now, that urgency is fake, because there's no possible way to get them now. domestically. It'll take like 15, 20 years to even start delivering on these promises.
And also, what are we going to use them for? Like where, like
yeah. It's to drive speculation, investment in said speculation, which speculation in mining is huge business. And like when China limited rare earth exports just temporarily in 2010, the world went crazy, and like over 410 or something like that, new rare earth mining companies just like sprang out of nowhere, and they all got all this money and financing. How many do you think are in operation right now actively mining? Like 2 or 3 of those 480. So like but they all, they made their money and they're just gone now, but they, without ever having to mine a single thing. So like it's, driving investment, driving speculation, driving fear, anxiety, things like that. So it's like, just keep in mind the temporal disjuncture that criticality creates, I guess.
It does give us a different perspective onto where we're standing and how the discourse is then created. So Zane, Lauren, thank you so much for your time, for joining us today on our podcast. It's been fascinating. And I hope that we continue learning from you and with you as we keep on understanding what e-wasting is and how it's connected to these critical materials and the energy transition as a whole.
Thanks so much for having us.
Yeah, thank you, Paulina. This has been great.
Thank you so much. So that was a great conversation about e-waste and the critical supply chain for renewable energy and technologies with Lauren and Zane.
We will now transition to talking about another part of the critical supply chain, lithium mining for EV batteries. For this topic, we will hear from Prachotan Bathi, a master's student who works for a clean tech startup that uses remote sensing and other technologies to identify sustainable lithium mining sites for the EV supply chain. So here's my conversation with Prachotan. I am here with Prachotan Bathi, a master's student in computer science at the USC Viterbi School of Engineering. He currently works in business development for a clean tech startup called Lysis, which focuses on identifying sustainable lithium mining sites for the electric vehicle or EV supply chain. So thanks for being on the show with us.
Thanks, Justine. Yes, hello everyone. I'm Prachotan. I'm a grad student at Viterbi, and I'm the best cook on the planet, as I claim to be.
Great. So just to start on a high level, what is lithium used for and why is it important for the energy transition? And also feel free to define the energy transition however you see fit.
Oh, yeah. So we talk about lithium and energy transition synonymically. When you talk about energy transition, there's always a talk about lithium, and lithium is extremely important. It is in fact classified as one of the most critical minerals by the US government. And it's important because it goes into the primary component of any electrical vehicles that you look out there. A battery, lithium has to be in there. And it's primarily important because of its high energy density, which makes it the most suitable electrolyte for an EV battery. For me, energy transition is about having a reliable platform to build a future innovation on. So we've been pretty much mining petroleum for over 1,500 years now, and we've suddenly shifted from, the whole industry has shifted towards an entire different spectrum. We're focusing on electric vehicles, making the energy more green and clean. And I think it's more of building a sustainable and reliable platform that we could ramp up our future innovations on and build our innovations on.
Yeah, thanks for sharing that. And where is lithium being produced? I believe most of it's not in the US. Is that right?
Yeah, lithium is everywhere across the globe, but primarily lithium is being mined in China, Australia, Argentina, and Chile. So China is of course the biggest refiner of lithium as we see today. But then the US has also got reserves. Primarily, you see lithium mining happening in Nevada in the US. But they only contribute a very minute part of the world's lithium production today.
Mm-hmm. And we are focusing on lithium today, but I wanted to kind of clarify whether is lithium the best metal that we have for EV batteries today, or are there other metals elements that might become a more sustainable option?
Um, I would say yes. The short answer is yes. There is a lot of research happening on finding alternate materials for batteries, but as we see it today, lithium is the best one we got. Like I said, the high energy density of lithium is basically the amount of density you can store per kilogram of lithium, which hasn't been, we couldn't find anything that would meet up with those levels. There's research happening on using sodium as an alternate mineral for making batteries, but yeah, lithium is the best we got today.
And are there currently, because lithium does have its drawbacks too, right? So are there technologies being developed to make those batteries more efficient?
True. Yeah, there's a lot of research happening on solid state batteries. So instead of using a liquid electrolyte, solid state batteries have proven to be more reliable in terms of safety. Though they are still, there's a trade-off between how much energy you could get and yet make a battery very safe and reliable on. So there's research happening, but all we got to do is wait and see. But there's another aspect to it too. Most of the lithium batteries currently we see today are using manganese, nickel, cobalt as the cathodes as part of the components of the battery. But then there's companies which are pushing for using lithium iron phosphate batteries, which use iron phosphates, which is cheaper, more safe and reliable, at least on paper. So there's a lot of research happening on those areas too.
Mm-hmm. So is that the main kind of drawback with lithium, that it is pretty expensive? And
True. Lithium mining is expensive. That is what's contributing, both economically and on an environmental front. Lithium mining is looking expensive. So that's the reason people are looking for other alternatives.
yeah, and that is kind of a good transition into the main part of this conversation. So it seems like EVs are being advertised as the future of transportation, as a sustainable alternative to getting around. The Biden administration has certainly made it a priority to increase EV charging infrastructure across the country. But there are also concerns with the environmental costs of lithium mining, not to mention human rights violations, but just honing in on the environmental side for lithium mining. And before we get into the carbon footprint of lithium mining itself, can you just give us a brief overview of how lithium mining works? How is lithium extracted?
True. So there's basically two ways of mining lithium today that are economically viable for companies. So one of them is brine-based extraction. So there's huge reserves of brine, lithium salts containing brine underneath the ground. So you drill holes into the ground, pump out all the brine, and then you lay them out in huge farms for the sun to evaporate the salts, or sometimes you use another external heating agent to uh, get your lithium salts. But the other way of mining it is through rock extraction or clay extraction, where you move huge chunks of rock, crush them, and extract lithium out of that. So the brine extraction is comparatively more sustainable and leaves a less footprint, but the other rock or clay-based extraction usually results in a lot of uh, land moving and thus resulting in a lot of disruption of local habitats. So these are the two, but there's also research happening on other fronts of finding other alternatives for lithium mining, better alternatives on how to do it.
And is lithium, or is the brine method the most common way of extracting lithium?
Yes, brine is the most common.
Yeah. So going into the environmental footprint of lithium mining, can you walk us through what are the impacts of lithium mining on energy and water usage, land degradation, toxic waste, any air and water pollution?
So like I said, usually with brine extraction, what happens is these farms might not have enough sunlight or enough renewable sources to evaporate the water in the brine and leave out the lithium bags. So usually end up using, in most cases, non-renewable energy sources. Specifically in Australia, if you see, coal is being used as the heating element for drying up the brines. So apart from that, when you lay out huge farms with lithium salts, there's a potential for the brine to leach into the grounds that where it is laid out for evaporation. And this is a cause for a lot of footprint that's happening out there. And they tend to pollute up, causing a lot of habitat destruction happening, uh, probably rendering those lands unusable for a fair amount of time. And then usually lithium extraction, lithium and like its family elements in the periodic table, yeah, they tend to form a lot of strong bonds in their salts, and it's very difficult to extract pure raw lithium out of it. So there's usually a lot of cost involved in terms of the energy that goes into extracting lithium and processing it. So, and we've also seen other social impacts of lithium mining, especially in the Democratic Republic of Congo, where child labor has been a very prominent problem in terms of lithium mining. So there's multiple phases through which we need to look at lithium mining as a sustainable operation.
Definitely, yeah. It's also really important to keep, it's not just about the environmental costs, it's a lot of social impacts. So would you say EVs are more carbon intensive to manufacture than internal combustion engine gas vehicles? Like, how much does it contribute to the overall carbon footprint of an EV?
Yeah, technically, yes. EVs are definitely more intensive in terms of the manufacturing process. When you talk numbers, it's about 7,300 kilograms of equivalent of carbon dioxide. So kilogram equivalent of carbon dioxide basically means the amount it contributes to global warming relative to carbon dioxide. So to manufacture an average Tesla battery, you have about 7,300 kilograms of equivalent carbon dioxide. So this number is definitely huge. It's a huge footprint. But on the other hand, if you look at an ICE engine, the estimate is about 2,000 to 2,500 kilograms of carbon dioxide, equivalent carbon dioxide every year produced by an ICE engine. And so that we're talking about over 3 years before an ICE and an EV are sustainably on the same level. But then petroleum mining is not a cheap effort. It's a very intensive and very expensive effort, both economically and also environmentally. In lithium brines, you're usually looking at shallower depths, but then in petroleum mining, you do a lot of deep soil exploration, which results in a lot more impact and footprint. So overall, EVs tend to do better across the lifespan, uh, despite having an initially high cost of environmental impact.
Mm-hmm. So you would say the lithium mining footprint is a little bit higher than for oil drilling. Sure. But that's a good point to make, that you're comparing, like oil drilling also has its cost of comparing the two across. So looking across a vehicle's total life cycle, would you say are EVs actually more sustainable than gas vehicles? Do the benefits of having zero emission vehicles outweigh those costs of lithium mining?
So when we look at it, over 3 years of an ICE's lifespan, you're already offsetting the cost of setting up, manufacturing an initially new EV battery. And not just that, if done the right way, there's a lot of research happening on economically viable recycle and reuse of EV batteries. So it's not always the 7,300 kilograms equivalent of carbon dioxide. That number keeps lowering down the lane because you tend to keep reusing and recycling what you initially manufactured. So overall, EVs are better. EVs have a promising future in those aspects.
Mm-hmm. Thanks for that. And it sounds like lithium will be a critical component of the energy transition, despite the substantial cost of it. So how can lithium mining become more sustainable, or are there any technologies already being developed or in the process of being developed that will make the process more sustainable?
Yeah. So the 7,300 kilograms of carbon dioxide equivalent that we talked, which goes into a Tesla EV battery, 40% of that is resultant from the initial mining and refining process. So there's definitely a lot of research being done on making the mining process better, Especially there's new technologies like direct lithium extraction, which are being employed by a lot of companies out there right now. They're trying out DLEs. So there's also a research going on into extracting lithium as a byproduct of other mineral operations, specifically bromine, um, and a lot of other processes like electrolysis to separate lithium salts. So all of this is happening, but then there's also the traditional mining operations, the brine and the clay and rock based exploration, which is happening, which could be further aided by technology out there. Something which Lysis is doing right now. We are focusing on using remote sensing to make and identify these spots better, the mining sites better, so that the overall footprint that a mining operation leaves is lowered.
I guess something on the lines of like, do you have any metrics for how do you identify like this is going to be a more sustainable site versus another site?
So what we are doing at Lysis right now is we are looking into what primarily is impacting mining. I mean, what kind of footprint is mining operations leaving around when they look for a particular site and they start drilling holes and start get on with the brine extraction. So we identified a multiple array of points, just starting from ecological imbalances that mining operations are creating, um, water pollution that's happening, the potential for using renewable energy, and also the social impacts. If there's any traditionally living tribes or any local communities that have settled in the area which might be impacted because of the operation. So we tend to give a overall graphical view about. So you choose in this particular location to mine. What other impacts is this going to have? Is there a habitat that's an endangered species habitat that is nearby which might be impacted? Is there a groundwater source which might be impacted because of the brine leaching into it? Are there what is the potential for using renewable energy here? Can we set up a solar farm to help with the mining operation? Can we use other alternatives here? Or if we tap into the electricity grid here, which kind of energy are we going to use? Are we going to use a thermal or coal-based electricity? So we're looking at a wide array of points here to give an overall heuristic view of what the environmental impact of that particular location is going to be.
Yeah, it definitely sounds like you're helping contribute to, using more sustainable mines to extract lithium. So to conclude, what would you say are the biggest challenges and opportunities of lithium mining, or what do you envision the future of lithium mining will look like?
Well, the biggest challenge is having a social license to mine in first place. That's one of the biggest challenges lithium mining is experiencing out there. But then the opportunities are out there too. There's new technologies that are coming up: remote sensing, artificial intelligence, drones, and these all could add to the making the lithium extraction process more economically viable, more sustainable, and the whole world is looking forward to it. And yeah, we hope it's going to be a bright future ahead.
Yeah, and is there enough supply in the ground to meet our growing demand? Is that a potential limiting factor?
Geologically speaking, there is enough supply of lithium, but then there's numbers around which say about 25% of that is economically viable for extraction. And like I said, with advancing technologies and with more research happening on reuse and recycle of lithium, so we might actually reduce the need for mining new lithium and, in fact, improve ways to sustainably mine the existing lithium. So I think we are good. We don't really need to worry about if there is enough lithium out there and if it's going to last our sustainability efforts and our energy transition efforts.
Yeah, that's good to know. And how robust are the current recycling capabilities? Is that something that's like commercially scalable at the moment, or is it still a more developing thing?
It's a developmental effort. There's research happening and there's proven results too about the overall lithium recycling processes. But usually when you talk about recycling and reusing in battery components, you talk about the cathodes, the heavy metals like manganese, copper, and cobalt and nickel. So a lot of current reuse practices or recycle practices look at those heavy metals rather than lithium itself. But then there's a lot of research happening on reusing the lithium electrolyte and lithium ions further too.
Great. Well, is there anything else you would like to share with our audience or anything you wanted the public to take away about lithium mining today?
Two things. Be a policy advocate, support and encourage policies that the government makes, policies that companies make to improve energy transition efforts, and then keep yourself aware about developmental efforts that are happening. Look out for new trends, new technologies that are happening in the energy transition space, and don't deter yourself from trying them out, because you you probably have a fair hand to play in the future. So yeah.
Well, sounds like you are doing some of these things. So I appreciate you sharing your insights with us, and thanks for being on the show.
Thank you, Justin.
So my takeaway from this is that there's no perfectly green solution to the energy transition. EVs and lithium mining come with a high social and environmental cost, but so does driving a gas vehicle. And it's up to us to decide what we're going to do about it, whether we're going to do more research on the EV supply chain and how we extract our lithium, to what kind of car we're going to drive, if we're going to drive one at all.
These conversations did encourage the need of rethinking criticality, because the energy transition is not just about switching from one source to another, but about transformation of our relationship with materials, with infrastructures, and communities. We also need to consider how our energy choices affect the environment, the economy, the society, and how we can create sustainable and equitable outcomes for ourselves and for others.
This episode was very interesting for me. I'd read several articles about the forecasted future demand for mining of critical minerals, but these interviews provided more insight into the renewable supply chain and the end of product life of some of these products we're using. I learned that it's important to ask the question, critical to whom? The state, the individual, the ecosystem, and ask really, why do we really need this? What does it impact? Zane commented, the good news is that we have a chance to rethink our energy systems from the demand side. The bad news is we must rethink an entire energy system and develop a new one. This may take a little longer than we think. Lauren added that digital transformation is intertwined with energy transformation. And data center demand is competing on a local level with electricity and water demands. And AI has become a significant new energy consumer. Each of our guests tells us that critical systems today are not sustainable and often not even possible, with a false sense of urgency that drives speculation. Their advice to all listeners was to get involved in local politics, that NIMBYism should not be criticized when legitimate local interests are ignored. We said from the beginning that the energy transition would be complex, and we are learning why.
Absolutely, Jim. And I do think that energy is not static, it's not a fixed commodity, but it's dynamic, and it's a complex process that involves multiple actors and interactions and feedback loops. So I think that we still need to understand how energy is produced, how it's consumed, distributed, stored, recycled, and so forth, and how these different processes shape and are shaped by our realities, both material and social.
Yeah, and it's also clear that the energy transition has impacts on communities, especially those that are dependent on or affected by the extraction, production, or disposal of energy materials. I think we need to acknowledge the challenges and opportunities that these communities face and how they can participate in or benefit from the energy transition. So the energy transition is up to the changes that we are willing to make as individuals and as a society. So until next time, we hope you understand a little more of the story of the energy transition, because the energy transition is up to you.
Thank you so much for tuning in to Energy Transition Talk. If you have any questions or comments, suggestions for topics you want to hear about in the future, or any other podcast episode, please visit our YouTube page. We welcome your feedback.
We would like to thank the USC Oshagi Center for Energy Transition, which aims to develop innovations in energy technologies and foster the transition to a low-carbon future, for sponsoring this podcast. Special thanks also to our guests for today and Abhi, our technical guru, for their important contributions to our podcast. Don't forget to subscribe so you can automatically get access to our new episodes. You can find us on Apple, Spotify, YouTube, or wherever you get your podcasts. I'm Justine.
I'm Jim.
And I'm Paulina, signing off from the Energy Transition Talk. Stay tuned for the next episode.